What use is all this lovely potential energy if we just blow our load all in one brief but fun moment? To make this magic moment last longer, we have to slow down the release of this potential energy. Gravity is such a fun way to store energy, and since the dawn of time, we found creative ways of using gravity to power things. For example, with this heavy rotor, we can now release the potential energy from the weight over a longer period of time, so we can do something useful with it. In today's video, I'd like to experiment with various means of storing energy using weights, and then releasing that energy into generators to power some electrical gadgets for a while. Can we make something that's actually useful? And for you LEGO purists, I'm also keen to see which LEGO motors work as the best gravity-powered generators, so you can power your own LEGO builds using standard LEGO parts. Now, when we think of storing and using energy from gravity, probably the easiest way of releasing that energy is mechanically. If we take this lever built onto a car's chassis, we can make this weird abomination that is powered by a lever that gravity can act on. Pop a weight on it, and off it shoots. Now, of course, this is wildly impractical, but a fun proof of concept in converting the potential energy of gravity into usable energy. Similarly, this gravity-powered fan allows us to turn this potential energy into usable mechanical energy. And by messing with the gearing output, we can decide if we want to release loads of energy at once, or slow it right down. Here, gearing up from 1:25 allows this fan to run for over a minute, while dropping a weight only about half a meter. Crucially, for a gravity-powered invention, we need to decide what we want to power, and for how long. Escapement mechanisms are a great way to slow down the release of energy even more. For example, this magnetic pendulum is powered by a wind-up LEGO motor, and it runs for about 2.5 minutes swinging the magnets between some coils, which generates a small current. And we can do exactly the same thing using gravity if we just want to power some very low-powered gadgets. In fact, this gravity-powered tick-tock jobby can run for 11.5 minutes by dropping a relatively light weight half a meter.
God, this weight is barely moving.
Let me know if you'd like to see me turn this into a very slow release generator. For today though, I want to extract at least a reasonable amount of energy to power some electrical gadgets. Let's see what we can generate and for how long. Starting with some standard LEGO motors, which we can of course use as a generator. Now at this point, I don't know what gear ratio to use as different LEGO motors have different mechanical resistances. So we'll give ourselves some options to test. Ultimately, I just want to know which LEGO motor makes for a reasonable gravity-powered generator, and what gear ratio gives us a slow release while still allowing us to power something.
So now here we have the spool, and on our first output we have 1:1. On our second output we have 1:5. And then on our final output we've got 1:25.
And this time I'm going to use a counterweight as I've already had several contraptions smashed to the floor while testing. So let's start with a standard LEGO M motor and direct drive at 1:1 gearing.
Let's try the old lick test.
And when I yank the cord... Yeah, well, it definitely generates something. Now, I don't want to destroy my LEGO cables, so I bought some knockoff cables and cut one to expose the wires. Now we can just attach this to any motor with the same connection. Okay, let's try powering one of these noodles. These guys require 3 volts to run and are quite power hungry.
Very nice.
Well, it can definitely run while pulling on the cable. So now we need to see if a 1 kilo weight can do this work instead of me.
This is probably about 2 feet falling from here to here.
I'll start with some low-powered LEDs that also need about 3 volts. Yep, works great. So, back to our hungry noodle.
Okay.
And this seems to power it easily, though it only runs for about 3 seconds. Okay, let's try gearing it up 5 times. Yeah, unfortunately this time there's just too much mechanical resistance, and the motor doesn't even generate 3 volts. Now, what about our big boy XL motor? We'll go back to direct drive with this guy.
Okay.
Wow, that's more like it. The output isn't quite as strong, but in total this ran for about 10 seconds. Much better than the M motor.
There's no way that's gonna work on the second gearing.
Okay, next up is a knockoff L motor. I'm just testing it because it has the same connection. And this one, like the M motor, runs for about 3 seconds. Let's see if it'll run when geared up 5 times. Well, just like the M motor, this also doesn't have quite enough torque to run. Finally then, let's try out the buggy motor.
Whoa.
That runs for less than 2 seconds on direct drive. And when geared up 5 times... yeah, pathetic. Just not enough torque to run smoothly, and it also doesn't generate enough voltage to run the noodle. So it looks like our winner here is the standard Lego XL motor powered by a direct drive. Next up, I wanted to try something to combat an issue I'm having. My desk is really only a couple of feet off the ground, so these platforms allow me to do something cool. The trapdoors are activated by a lever on the floor, and we can put a weight on the trapdoors. You can see where we're going with this. Once we've placed the weights on each of the trapdoors and connected each one to the main string, now we're storing a bunch of potential energy. When a weight is released, it'll travel down its elevator shaft, hitting a lever at the bottom, which activates the next weight in the series. This allows us to build horizontally rather than upwards. And in theory, this is modular, so we could create a whole bunch of weights on pulleys that just keep injecting energy into the system.
Yeah, a bit pathetic.
However, I soon realized that I totally over-engineered this. We don't even need these trapdoors. If I remove them and then just wind up the weights, each of the weights will stay in place. Only the weight with the lowest mechanical resistance will fall, and then the next, and then the next.
Whoops. Yeah, I don't need that bit.
A major downside though is that resistance builds for each successive pulley system, making the final weight contribute a pretty pathetic amount. Oh well, cool idea though. I'd love to get back to tackling this idea at some point. Right, well I think it's time to get back to basics and make ourselves a generator from scratch. Something a bit more to spec for our gravity power needs. Now here's the first of 3 coils using 27 gauge wire. And to run buttery smooth, we're going to use some of these cool metal bearings. I'm also going to use an aluminium axle so we can comfortably add weight to it. Now for the gearing, our final output will be 45 times faster than the input. And we'll want to make sure this thing is sturdy, as it'll be under a fair bit of strain. Let's give her a quick try. Pretty good, I reckon. Now, let's prepare our generator core. These large neodymium magnets have a hell of a magnetic field, and I think this rotor should be able to spin incredibly fast if we add enough weight. So we'll pop her onto the output. Right now, however, the rotor is annoyingly attracted to my metal table, so I can't rotate it much. Now, to capture as much of this magnetic field as possible, we're going to go for a 3-phase generator, with 3 of these coils surrounding the magnets at 120 degrees from each other. With our 3rd coil in place, we're now surrounding the core. But we still need to get over this issue of the metal table. And you know what? FlexiSpot is exactly what I've been needing. A big thanks to FlexiSpot for sponsoring this video. This beauty of a desk is the FlexiSpot E7 Plus. The whole thing comes together easily like Lego, and these powerful motors built into the frame have been a game changer for me. Now for those who don't know, outside of YouTube, my day job is in medical education, which has me sitting at my desk all day, ruining my back. But now, with a simple press of a button, this beautifully engineered thing extends its robust legs, allowing it to transform into a standing desk. Now, I've been using it for the past while at work, and I can't describe the difference it's made to the end-of-day fatigue on my back. No matter how tall you are, this desk will absolutely get enough height for you. It's incredibly sturdy, even while extended. And with a 540-pound weight limit, you can load it up, and also operate it under heavy load. I can even use it to add some extra energy into my gravity generator. I'm not quite 540 pounds, but it lifts me easily and doesn't even register the weight. For me, this is a game changer for building my inventions and filming my videos at any height I want. But what good is an incredible desk if I'm still scratching the hell out of my landlord's floors and ruining my back with my uncomfortable IKEA chair? Fortunately, FlexiSpot provided this wonderfully comfortable fabric ergonomic chair, so now I can zoom around while filming and at work without destroying our floors. It's the perfect companion for the standing desk, and makes for a much improved office experience. So check out FlexiSpot if you're looking for a rock-solid standing desk, or the best of ergonomic chairs. With a 15-year warranty, the E7 Plus is an investment for your workspace. Use my promo code YTE7P50 for $50 off the E7 Plus. And if you use my code C730, you can also get $30 off the C7 Max chair. So follow my links in the description below. Your back and your projects will thank you. A big thanks to FlexiSpot for partnering with me on this video. Well, now that we thankfully have a non-magnetic surface, we can finally get this generator running smoothly.
Let's see what she's cooking with. Whoa.
And fortunately, she's outputting something pretty tasty. So can a single coil power the noodle? Sure can. Then using this 3-phase full bridge rectifier, wink wink electro boom, which we'll pop in here and connect to the generator, we can now combine the outputs from all 3 coils into a single smooth output at 3 times the current of a single coil. Okay, back to our trusty noodle. Now we'll have to wind her up to get her started, and yeah, this is as tedious as it looks. With an extra kg, let's see how she fares.
Okay, here's hoping this works.
By the way, if you like these experiments with Lego and technology, feel free to subscribe or drop a like. And if you'd like to see more behind the scenes footage of how I make these things, you can find me on Patreon too, link below. Okay, we can easily get 3 volts, but what about these 12 volt bulbs? It'll need to spin a lot faster to power these.
Okay, here's hoping nothing breaks.
Good lord, this thing sounds vicious.
Whoa.
It only runs for about 6 seconds, but we're getting a tremendous output. And what voltage are we getting if we attach only a minimal load?
Okay.
Looks like just over 12 volts. Question is, how long can this thing run for? Let's use a bunch of noodles and a drop distance of around 1.5 meters.
And we'll use a stopwatch to find out how long this runs for. Here we go.
Now, speed us up a tick.
There we go, bang on 25 seconds.
However, we have a major issue. As you've likely seen, it's a real pain to have to rewind the mechanism every time I want to run it. My thumb is actually quite raw filming these takes. And that's why we're finally going to embrace the mighty Huygen's mechanism. These pulleys here are the start of an ingenious chain drive contraption built by Christian Huygens. It was originally used in clocks, and the simple but clever mechanism allows you to easily add energy back into the system while it's in operation, by either raising the driving weight or turning a ratchet wheel. Now you'll see how cool this is in a minute. Now once again we're going to use bearings to support the heavy weight and keep this thing buttery smooth. This ratchet then will be key to control how we add energy back into the system. Now these 2 wheels together will serve as our winding wheel, and their shape is important because it'll allow us to hold our drive chain in place. Now you can see plenty of friction here, which is good, allowing us to drive the wheel, but only in one direction. Now I was going to use a real chain, but I was skeptical it would hold real weight without snapping.
I don't know about this.
Then we need our main wheel and gearing.
So this is just a simple gear reduction. So 1 rotation here, we'll turn this 25 times. Once again, we're going to use our bearings to make this as smooth as possible. We've got 1 over here, and on the output 1 over here.
This runs buttery smooth and will run even better when there's weight on it. So once we marry these 2 bits together, now we can bring in our main wheel. For the main wheel, we're going to use this large squidgy Technic F1 wheel, because it has tracks in it that the string will sit into. For now we'll hold it in place using a regular axle, but I'm going to use an aluminium axle when adding some real weight to it later. Now, when we pull on the main wheel, you can see we get a lovely fast output. So far, the bearings are doing their job well. And fortunately, this nylon string has loads of friction against it due to the squidgy tires.
That grips really well.
Now, because we're building a 3-phase generator again, we're going to need to mount our coils 120 degrees from each other. So this setup here should hopefully work. And of course, a final bearing to support the main rotor. Then, of course, we'll need our rotor. Now I'm going to mount some fairly large and very strong neodymium magnets because for once, it's actually beneficial to have a pretty heavy rotor. Because they're strong, they won't have to move too fast to generate a high voltage.
Man, these things are strong.
And the weight will have it start fairly slow, meaning it'll run longer when supplying low voltage gadgets. But rest assured, it should be able to spin up real fast for some higher voltage demands.
Whoa.
As I'm doing this, I'll stress again as usual that if you're going to mess around with strong magnets, please be super careful. These things can get pretty dangerous and I've developed a real respect for them. And of course, while building this, the metal table was a real pain in the ass. But once we remove the guards, here we go. A lovely powerful rotor with 4 magnet sandwiches. So let's stick this thing on the generator axle. Runs smooth. And when we support it on the other side as well, yeah, there we go. This thing is so smooth. Must have run for about 40 seconds over a single push.
Wow, that just keeps going and going and going.
Now, importantly for this generator, I'm going to use 400 turns of thin wire per coil, so I want a relatively high voltage. This is so that we can power just about anything, so long as it doesn't require much current. Just to check, let's see how this single coil does with the noodle. Very nice. The idea here is that the generator rotor will spin up to whatever speed is needed by the electrical load, and then will hold a certain speed while that gadget begins drawing power. You could of course use other rotor and coil designs, but I found many of them, like this one here, just weren't very efficient and often didn't run very long. I'm very happy with the current setup. To test this whole mechanism actually works, let's start by using this relatively light weight. And then this even smaller weight will serve as the tensioner. Then comes the fun part. Feeding the string through all these pulleys. Well, finally we have 2 loops onto which we can mount our driving weight and tensioner. Okay, let's see this wonderful mechanism in action. The ratchet allows us to simply raise the driving weight, and the tensioner keeps the ratchet closed. Then when we release the weight, it pulls on the driving wheel, turning the generator rotor. Now of course, it starts slow here, as we're currently using a relatively light weight for the driver, but after a while it picks up some pretty impressive speed. I'm absolutely delighted by how well this runs. Now the cool thing is we have 2 ways of adding more energy into the system. For the first way, we can wind the winding wheel, which is connected to the ratchet. You can see while we wind it that it's raising the driving weight while in operation, so if we wind this we can make it run even longer. The ratchet also benefits us, as the mechanism will continue to freewheel once the driving weight hits the floor. Of course, the other way that we can add energy to the system is by simply raising the driving weight again, which you can fortunately do while it's in operation. This will momentarily reduce the power to the drive, but you can add a lot more energy in one swift movement. I guess if you have a standing desk, you actually have a third way of adding energy. Okay, now we know all of this works, let's add our coils and find out if this thing is actually useful. Before we add a real weight though, I wonder if this light weight and a single coil can light up this noodle.
Okay.
If it can, this will bode really well. Yeah, I'll speed this up a little. And yep, this works excellent. I think when we add a real weight and triple our output, this thing will be quite capable. So let's use this 3-phase full bridge rectifier again to combine all of our coils into a single output. Once she's all hooked up, let's finally upgrade to a 1 kilo weight to start with. With a kilo on here, the rotor spools up real fast, immediately lighting our noodle. In fact, for these noodles and a drop distance of about 3 feet, we get a full minute of runtime.
It's amazing how silent it is.
We can even add more of these noodles, no problem. Now to me, I think this makes the contraption actually quite useful. We can easily graduate to these 12-volt bulbs, and these give off quite a bit of light. Enough for a night light while using the bathroom, if you're quick enough. Even adding a few more bulbs works really well, and they run for quite a long time. I always find these bulbs absolutely beautiful. I still find it weird how silent this whole thing is. I'm used to most of my generators making a hell of a lot of noise. Now we can of course also power a whole bunch of LEDs on a strip like this thing, though you can probably tell that the current produced isn't amazing. And what voltage are we getting, assuming we have a minimal load here?
Okay.
Now at this point, I forgot my capacitor is only rated for 16 volts. And I really didn't even think we'd get up that high. But I guess when there's minimal electrical load, this thing builds up some tremendous speed. I'll speed this up a little, and it looks like we easily hit just over 17 volts.
Whoops. That's a little more than the capacitor's supposed to take.
So this got me wondering, I've got some of these longer, hungrier green noodles that need 24 volts to run. Absurd, I know. Can we light them up? Now it does take a bit of time for the rotor to spin up to speed, and I'll speed us up slightly again.
Whoa, there's some speed on the rotor. Hey! Oh.
Now, it was short-lived, but we just about got there. If we had a longer drop distance, this would be real fun. But can it power something hungrier like my phone? On my first attempt, it looks like the resistance is just a little bit too much, and the 1 kilo weight just isn't quite enough. So after adding another kg to the drive weight, let's give this another try. And voila! We can indeed charge our phone from this.
Hey!
Though apparently we'd need 917 kilos to fully charge this phone over 1 hour, so perhaps we're a little short. So all in all, I'm going to call this one a success. Check out FlexiSpot below using my links. Let me know if you'd like me to experiment more with an extremely slow release generator like this jobby with an escapement. Cheers!